This is Problem Solved, the IISE podcast, where we talk to industrial and systems engineers about their work, ideas, and solutions.
Hello, everyone. Welcome to Problem Solved, the IISE podcast. In this episode, we're going to talk to an industrial engineer who is in charge of a NASA project to return soil samples from Mars. I'm Dr. Barrett Caldwell, professor in the School of Industrial Engineering at Purdue University and a member of IISE. I'm also the director of the Indiana Space Grant Consortium and a member of the Apollo 11 50th anniversary mission team at Purdue. Joining us today is Angie Jackman, the project manager for the Mars Ascent Vehicle at NASA's Marshall Space Flight Center in Huntsville, Alabama. Angie is a native of Montgomery, Alabama, and began her career as a reliability engineer at the Marshall Center in 1985 after earning a bachelor's degree in industrial engineering from Auburn University. She now leads a team focused on developing a rocket to launch the Perseverance rover's collection of rock and soil samples from the red planet into space. She is involved in all aspects of the operation, including engineering design, management, procurement, facilities, and business. Angie, welcome to Problem Solved, and I'm glad you're here to speak to our audience of industrial and systems engineers and general space fans.
Great. It is good to be here. I'm happy to spend the afternoon with you chatting about space and the Mars sample return mission.
Well, it is among our favorite things.
Excellent.
Starting up, growing up in Alabama, what were your initial impressions of NASA and the Marshall Space Flight Center?
You know, I was afraid you were going to start with this because I really was not a space nerd. I had to grow into being a space nerd. Montgomery is a fair amount of distance south of Huntsville, and I was 6 when we did the first moon landing. So I was really not that aware, other than the general public awareness. And I was an inquisitive kid, but on different things. But the neat thing about Alabama, in every 5th grader, I don't know if they still do it, but they used to, that we had the opportunity to come up to the U.S. Space and Rocket Center. And that was a little bit fascinating. At that age, though, I was more interested in the space monkeys. I thought that was the coolest thing. Miss Baker was still alive back then. And the size and everything was very overwhelming, but I really never thought, that as a career. I thought that was very neat and fun. But, my world and my family was, there weren't any engineers. So I was one of those kids that, really didn't know about engineering and kind of grew into it later.
So if there were no engineers in your family, what initially drew you to major in IE at Auburn?
As I've talked to, fellow engineers, as you do over the last, decades, it, I think, is a really common story, but it's a lot of us didn't know engineering, but we were good in math and we were good in science. And, you just kind of go down that path. My mom was a microbiologist. My dad was in sales. I didn't really have that exposure, but I do think, it was just part of my DNA. I had a friend, that I played sports with. She was a year older than me and said, hey, she was going into computer science. And I thought, that's interesting. I wonder what that's all about. And so I went to Auburn, and that was my first career path, or, educational path, I should say. Of course, the first couple of classes, I just went, "Ooh, no, not for me." It's a little too, formulaic for me, and rule following. And so I gravitated to, just friends that were in, engineering curriculum, and kind of talk more with them about what it was industrial engineering and other options, and industrial just kind of fit my calling and my nature. So. I really loved it. I loved all aspects of it. It's kind of sounding up, a little serendipity, but I think part of it is just intuition. And I think it just fit with me.
Great. And I think one thing that's important for the audience to realize, especially younger people, is that there's always a question about what's the royal road? What's the specific path? How do we get exactly to the end?
Exactly. Exactly.
And you're not telling that royal road sort of story. But following up on that, though, how did you end up at Marshall? I mean, if you weren't a space nerd and you weren't really thinking about working with NASA as a major life choice. How did you end up with Marshall with a bachelor's in IE rather than one of the other engineering focus areas?
I ended up just being very lucky. At the time in the mid 80s, NASA Marshall in particular was having a lot of co-ops and was about to do a massive hiring. There's a wave of us that all came in together in the mid 80s. So they came down to Auburn and interviewed. I interviewed in that, but I also knew several folks that were co-ops and they really enjoyed the work. And so it was just really kind of word of mouth, networking kind of discussions that brought me to Marshall.
So you came on board in 1985 as a reliability engineer. Mm-hmm. Let's say the first 12 months were probably a little bit challenging for you as you started working through. How did your IE training help you with those early roles at Marshall? And I should say, including looking at the aftermath of the Challenger explosion.
Yeah, I hired in October, about 6 months prior to the Challenger accident. And as you had mentioned, I was a reliability engineer. Had a great organization, and they wanted me to start focusing on failure modes and effects analysis. How can the hardware fail, and what would happen, if it fails certain ways? There was a satellite program called Tethered Satellite that they wanted me to work on, and it wasn't going to fly for 6 to 8 years. And boy, as a 22-year-old, I just thought that was forever. And so I was enjoying the work, but when you work with some other designers, especially young designers, they didn't want to bother, with the reliability study. So I was kind of struggling a little bit. But then the accident happened in January, I got involved in the investigation, just, a very minor role in it. But, I thought that was just, trying to contribute to finding out what happened was really impactful. Then when the investigation was over, the product or the analysis that they were going to use to get to return to flight was the failure modes and effects analysis and the critical items list. And so they assigned me at all of, 22, 23 years old, working on the external tank program. And that really changed my course and changed my career, and fell in love with NASA. Because NASA, the complexity and the interactions of that program, that whole space shuttle program, is just mind-blowing, and all the details. And so with doing the FEMA SIL, they had to start at ground zero and work through every component, we as a team going through all those failure modes. And it took, a couple of years to do that, but it really was it was a huge tragedy, obviously, but it really was an experience for me that opened my mind up to what NASA did, the challenges of it, the people. I got to work with really some of they were probably my age now, but they were, the graybeards of the day, and got to really learn from them. And that was just an amazing opportunity. And so it just kind of grew from there. And so really, as an IE in that world, it was really, how does the system work together? You have your specialists in each little discipline, but that's really kind of how systems engineering at Marshall works, is you're really looking at everybody can dive deep on their components, because we have very specialized expertise in areas, but you have to raise up and look across them and see how do they interact. And as they do their individual analysis, does that roll up to tell the story and have you ready for, to return to flight? Does that make sense?
Yes, it does. And in fact, it reminds me of my experience probably at the same time. As an undergraduate, systems engineering was maybe that thing that you did if you weren't that much of a specialist, but you weren't so bad that they had to fail you out of the Aero program.
Right.
And I'm sort of impressed with the story from the perspective that NASA has had a long involvement with systems engineering concepts and systems engineering education, including the programs at UAH, where you did, in fact, study as well.
Right.
Given that early experience and given your exposure to the Challenger return to flight, how, in your opinion, has systems engineering as a concept changed during your experience at NASA?
Yeah, that's an excellent point, because when I've talked to schools before about industrial engineering, and a lot of them don't really realize what industrial engineering at NASA does. But it's very different from a lot of how we're trained, in that we produce very few but very specialized and complex things. We're not about efficiencies. We're not about streamlining a process to make it, cheaper, or produce it faster. We're more about optimization. These pieces of hardware or analysis all have to come together, and you can't optimize for just your particular area. You have to look across the system and make sure everything is in balance. And so that's really important as a system thinker for what we do. So, we don't really produce a lot of the hardware. Our contractors do most of that. We're mainly a design and engineering center. And so, industrial engineers or systems engineering is kind of where industrial engineers, start focusing. We do a lot of requirements and verification work. We do configuration management, not only, the hardware, but the data and the analysis. How does that all come together? How do you control your configuration? We do mass properties, because it's very important, because launching vehicles, you're very much, the thrust to weight ratio aspect. We do integration. We do interface management. So a lot of, we work by systems. And so what is the interconnection, either functionally or physically, between all these systems that had to work together? And risk management. And that the risk is really a tool as a project manager that I really like, because I want the team not only focus on what they're doing today, but looking down the road and saying, where's the problem I'm going to have? And how do I, it's that thinking ahead part, that can be, when somebody's down in the depths of their analysis, getting the rise back up and, okay, look down the road and say, okay, what if this didn't work? How do I react to that? So that's one of the things I love watching the team as they do that. It's not a failure to think that way. I really want them, it's not a failure of what they're doing today, but it's just that planning and contingency planning that I want them to think about. Other areas of industrial engineering at Marshall is a lot of it engineering economy. A lot of our folks started out in the resource management offices and have become business managers. We do ergonomics, especially, our payloads work on space station. How do the astronauts work with those payloads? Safety and mission assurance, reliability, where I came from, statistics, operations research. So industrial engineering and systems concepts, is really broad and has a lot of opportunities for what we do. And I think what UAH has done is, because we're very similar to the Army in a lot of aspects, and they kind of help us develop at a graduate level, those skills, and also help us modernize our tools. One of the things we're trying to incorporate now is model-based systems engineering. And so I have a young, recent graduate out of UAH working on that. And but as manager, I have to balance it a little bit. So I'm not going to go all in. I'm going to make her prove it. But I really want her to succeed, because I think tools like that have huge potential, but I want to baby step them in.
I think you're raising a really interesting element there. The tension between, well, I want to do it myself and check the numbers versus, oh, that's right, I need to delegate.
Yeah.
So what does a week for you look like as a project manager rather than as a specialty engineer at this point?
A week for me is really, because the project we're in right now, we're still in formulation. So there is a lot of strategy involved. There is a lot of team building involved. There's a lot of communication, making sure people understand what their roles are, that they have to work as a team, Marshall and NASA's, I mean, that's how we operate. We operate on teams. We don't operate as individuals. It's a collective process to do these massive missions. And so there's a lot of understanding what you do and the value of what you do and how it interacts with somebody else and their analysis and the value of their analysis. So a lot of what I do, setting up that network and setting up, that, relationship with the different groups. And a lot of what I do with that is the schedule. I mean, it's really a basic tool, but it's a tool that, we do, kind of incremental planning. We do it in phases, kind of that rolling wave approach. And so like for the next year, we're right in the middle of what should this next year look like before our next major review? And how do we do that detailed planning? And a lot of that then becomes, here's my work and I'm dependent on you and you're dependent, this other person's dependent on me. So, that teaming and the responsibility for ourselves and understanding that piece of it. So, it's not quite as sexy, but that's, and it's kind of hard to describe what my week is because a lot of it is that the communication and making sure that's happening. And again, like I mentioned before, like on risk or that planning, getting folks to step out of their little area and look down the road and make sure what we're doing is kind of helping the mission.
I want to circle back to a couple of things that you just said here, especially because a lot of the undergraduate engineers always argue about, well, why do we have to work on these presentations and all of this?
Right.
And I think one of the things that I found fascinating from your too short resume about too many experiences, you've had a number of different positions on different programs, not just at Marshall, but at other NASA centers, and even some time at headquarters inside the Beltway. What have you learned about working with the other disciplines and groups? And you've really emphasized NASA as a team environment. What did those different rotations, different experiences give you as the best takeaway for working with the other disciplines?
Yeah, I really enjoyed my time at Marshall and NASA because NASA does give you those opportunities to, if you want to stay in the same area and become a specialist in that area, absolutely. That's, your opportunity in your career path. I like a challenge and I like change. That's just kind of how I work. And so I've gotten a lot of opportunities to go work on many, many different missions. And really, like I said, like you mentioned, at other centers also. And so whether you're building a spacecraft to go to Europa or performing science on the space station or building rockets like we do at Marshall, understanding, I keep harping on this is, what is your function and the team's function ultimately with the mission in mind? How do all those pieces fit together? And like you said, people don't like doing presentations, but that's kind of the format we use a lot for communication. And how do you take the message out of what your analysis does? And that's really something that's a part I always love too, is teaching the folks, as a manager, I'm not going to check your math. Your department should be checking your math, but I want to know what the message is out of what you have done, and why do I care about that? And so a lot of that is the communication, and not only, for me, to hear it as a project manager, but the other parts of the team, whether it's, a thermal analysis or, the latest Triple E parts discussion or, it all has a part, but it all has to kind of fit into to the larger picture. And it all has to, again, I keep harping on that. It has to work together because it's kind of, a theme that we have is that, we've, at Marshall especially, we are very specialized in our disciplines of what we do, whether you're, evaluating turbine blades on an engine or you're doing a thermal analysis on, something, that's cryogenic temperatures. It's all very specialized because what we do in our environment is very specialized. Not everybody works in the lack of gravity or just the forces and thrusts that we have to produce in our engines and the temperature extremes between hot and cold. That's all, very unique. And so they are specialized areas of discipline, but they all have to function together. And so I think that's where, industrial engineers really kind of help. And that's where, as a natural evolution as a industrial engineer into project type work.
Okay. I think I may be hearing a little something about communication here.
Just a little.
That sounds like a very important requirement. And I guess when you're talking about Mars Ascent Vehicle, I mean, okay, that would be a critical path sequence to be in charge of getting soil samples off of the Martian surface. What does that feel like? And do you really need to actually motivate people beyond that to want to communicate and work together? Or is it just say, we're talking Mars dirt?
Yeah, it sells itself. It really does. I mean, it's just, and especially working with JPL, they have a great way of communicating why we do these missions and the complexity of these missions. And so for, and the Mars 2020 rover, Perseverance, is on its way right now. And, the whole team, watched it remotely, as you do in this time. And it wasn't required, but everybody just did it because they know that's the really important first piece, and that had to go successfully. And so that was very exciting. And the other really exciting thing about this mission, the whole sample return, the Mars Ascent Vehicle is just one small piece of a very complex and challenging mission that all interrelates. And so with the Mars 2020 rover, it's going to land, it's going to do its science, but it's also going to be collecting the geological samples, as you mentioned, and they'll be depositing them either on the surface or carrying them with them or putting them in different cache locations, waiting for us to get there. And so there's a lot of science to be done independently of us for the Mars 2020 rover, but we go with two other launches. The Europeans are heavily involved in this mission, and they're going to do the Earth Return Orbiter. And that's the orbiter that will be circling Mars and waiting to bring the samples back. So we go as part of the sample retriever lander. We're a payload. And that's kind of a really odd thing for a rocket person, that we're going to be riding horizontally and not vertically, as we leave Earth's atmosphere. And so a lot of, our folks are really struggling with that, but it's just kind of a fun little struggle. But we get brought to Mars and we are landed carefully on the surface, and we are there, and we're in a little igloo, and they're going to keep us nice and warm and toasty because it's cold where we're going. It's minus 70, but they'll keep us at minus 40 degrees C. But then there's also a little fetch rover that the Europeans are going to build, and they're going to deploy that. And it's going to go pick up those tubes. I love watching that because your system thinking, kicks in is, what samples are most important to them? Where are they located? How are they going to get them? The combination between the two different rovers and bring them back to the lander, and they're going to load them onto Mars. But, that's just a little side note of, thinking about the logistics of, and the battles that, are going on about which samples are most important. But they're going to then load those samples into the nose cone of us, and then we launch. They're going to toss us up in the air, just like if you've ever seen a submarine launch of a missile where it breaks the water, then it ignites. That's kind of a little bit, of how we're going to do, because that way you really decouple, any interface. There's no potential for hang up. That we would be dragging the lander with us with all our thrust,
yes.
Or that or the lander might get caught up in the plume, and would it circle back and impact us? So it's really kind of a lot of people really struggle when they think about being tossed in the air. But then you after you get over your initial fear and gut reaction, it does make sense for them to do that. But then we have a 2-stage vehicle, and we carry those samples in. To orbit, to a predefined orbit. And then that way the Earth Return Orbiter can rendezvous, collect those samples, they'll clean them and bring them back to Earth. And so for us as a team, understanding why we're doing this, that, what is the mission? And the mission is the science. The benefit is we get to really build a cool rocket. I mean, it's not that big. I mean, we're a little over 9 feet tall, so we're not a big rocket. But we're going to be the first rocket, to be launched from another planet. And like I said early, that does sell itself. But emphasizing that to the team and communicating that to team and having the team all speak to that language is really important.
Wonderful. From where I sit, it sounds like you've turned into definitely enough of a space nerd for any of the groups that I ever sit down with.
Okay. And I grew into it.
And by the way, for anybody who's worried, yes, I do know that the term is regolith.
Nice.
What I'm really enjoying from this, you're describing, and we've really been talking a lot about diversity and communication and inclusion from a lot of different perspectives. If you don't mind, I'd like to make this maybe a little bit more personal and talk about some other aspects of diversity and how you might have seen this concept evolving over your career at NASA in terms of diversity of people.
Yeah, that's it's a great topic that I love because NAV needs to be a creative and innovative mission and vehicle, and to get that, I love diversity and having people from all different educational backgrounds, ethnic backgrounds, age backgrounds, gender backgrounds, LGBT, it doesn't matter to me. I love the diversity and the ability to bring things from a different perspective into what we're trying to do. And the inclusion part is part of my responsibility to make sure all those voices are heard and that they're given fair opportunity to be heard and considered. And so I really think, that enables innovation and it enables creativity. It's something Marshall really believes, and the leaders at Marshall really believe. It just makes us a better center and it makes us a better family. I mean, really, we do talk about Marshall as a family a lot, and I think that's part of it. And so being respectful of our differences and reaching out to understand that, I think is a big part. When I started at Marshall, there was that big wave of us being hired. And so there was a lot of females being introduced to the workforce that were engineers, which was a little different. And because of this career path that I got to follow, going into an older organization, a lot of times I was the only female, or especially the only female engineer. But having gone through engineering, that was not that different for me. So it isn't, I didn't feel, that uncomfortable with it. But, looking back on it 30 years later, I think it probably helped me because I think most of the men I were working with looked at, me as their daughter. and so I think there was a lot of nurturing, of me and trying to enhance that. So it's been really fun to watch Marshall grow in this area. But I think, again, like I say, I think it's something we obviously embrace. But I think with that there's been a growing curve at Marshall because we were historically a very hierarchical organization. And it's grown much more into an inclusive organization. So I think it's really made us healthier and more innovative.
Very nice. And I think it's interesting as you're describing it. I believe you said something about your student working on model-based systems engineering is also female.
Yes.
And I get the sense that she would have a very different experience because, and I admit that I was surprised looking at the number of female engineers, female industrial engineers in crucial leadership roles at Marshall, like Jody or Lisa. Or can you tell me a bit more about, for people who don't understand NASA titles, can you tell me about the range of the project roles that somebody like a Judy Singer or Lisa Watson-Morgan would have?
Yeah. So Jody Singer is our center director, and she has been in that role a couple of years now. She was the deputy before that, and she's just had a ever evolving and increased responsibility as she has grown. She was in the external tank project also, and she was a resource analyst, and so she was not in what Marshall is known as for your hardcore engineering disciplines. She was not a propulsion engineer that analyzed the stress on a particular piece of hardware. But what she does and what she's able to do, and same with Lisa, they are system thinkers. And so they can make sure all the pieces, and whether it's the institutional side of the house or the engineering side of the house or a particular project, make sure they're all functioning to the same drum and to the same path that the leadership wants. And so it's really quite fun watching her growth and her pattern and her career path. And she does very well at it. She's very strategic, and she knows herself, and she knows her strengths and weaknesses. And so she, surrounds herself with people that balance her out, which is really, what you want in a manager, and not the pretense that they can do it all. Lisa is also, she's a PhD in industrial engineer, and she's heading up the human lander for the Artemis missions. And so also, again, a very extremely responsible position. A very large program, a lot of contractor involvement, a lot of other centers involvement. So it's a very, again, another one of our big complex missions. But then, like I said, there's, business managers, there's procurement specialists, there industrial engineers, just kind of fit in a lot of different places. But I'll tell you the story that my husband is one of the managers at Marshall, and the engineering organizations were coming up with the staffing plans and the new hires and who they wanted to hire. And of course, it was, aerospace engineers, electrical engineers, mechanical engineers, and there were no industrial engineers on the list. And they just scratched their head, and they looked around, and Jody's an industrial. My husband's a scientist. There was a physicist in the room, and I think a computer scientist were the four leaders at the center. And they went, if we're also looking to hire the future leaders of the center and the future thinkers and the system thinkers, we need industrial engineers. So I thought it was a fun, and I didn't influence him at all in that decision. It was, completely independent from, their perspective. And I thought I love telling that story.
That's fantastic. And I think it does speak to the skill set that you bring, and not just the name of the discipline. And I think that's a really important lesson for a lot of us to think about, as well as the emphasis on systems thinkers and people who can see and connect the different pieces. This is wonderful stuff. I do have to ask you one more question.
Yes.
I don't know if this is sensitive or concerning, but where does the senior management come down? Roll Tide or War Eagle?
Again, Jody is an Alabama graduate, but she knows that she needs to balance that. So she maintains neutrality publicly, but I'm sure there's a lot of red and white in her home.
Well, I'm glad to hear that the rivalry does not take over the unified and the coherent and focus on the mission success.
Right.
Angie, this was a fantastic, fascinating discussion, and I'm sure our audience is eager to learn more about Mars because of you and your team's effort at NASA. Thank you so much for joining us today.
Thank you. I enjoyed it very much. And look for our launch in 2026.
Thanks for listening to this episode of Problem Solved, the IISE podcast, a production of the Institute of Industrial and Systems Engineers in Metro Atlanta. This podcast is produced by David Brandt, Keith Albertson, and Michael Hughes, and edited by David Brandt. You can listen to all episodes of Problem Solved and learn about sponsorship opportunities by visiting our website, podcast.iise.org. You can also learn more about IISE at the Institute's website, www.iise.org.